Hey, sorry what happened yesterday. We didn't get to do our meetup in person. For some of you, you were able to attend our little side discussion, which was really cool. But I promised I'd get you the content, so we're going to do that. As much of it as we can get you. We connected, if you were there in person, working on a better venue with more space. I'm the host for this meetup locally in New York, and I often speak at the event. Here's my contact information. If you'd like to learn more about Milvus, unstructured data, AI, different stuff, reach out. We try to run a respectful and open discussion. We want everyone to be able to communicate, be considerate of others. We don't want people yelling and arguing. This is just a open discussion of AI and data and vector databases, unstructured data, all kind of cool stuff. If you'd like to speak, definitely reach out to us. If you see anything going on that's not appropriate, definitely let us know. We don't approve of that in person. Obviously, virtual, a little different. If you want to get started, you could very easily use the open source, whether you're doing it in Docker, Kubernetes, bare metal, wherever you want to run this. Or if you want it even easier, just go to the cloud. You know how that is. We are hiring people. Again, I wish we were in person. When we're in person in August, we may have a slightly different list here, but we're looking for a bunch of different people all over the world. So definitely reach out and take a look. On Discord, we have a very large community, a lot of cool chats going on, a lot of great questions, people posting cool stuff all over the world. So definitely check out the Discord. Again, if you want to speak, we're a little busy for the next couple of months, but we would definitely love to get speakers. Anyone who's doing anything with unstructured data, AI, Gen AI, ML, vector databases, or anything cool in the area, real time, that kind of stuff, reach out, let us know. Have you built something really cool with Milvus or the Zilliz cloud? We definitely want to hear about it. Share your story, get some cool swag. Coming up, if you're in California, we have a AWS Community Day event we're going to be at. It's really cool stuff. Definitely scan it and head out to that free event. Very cool. And everyone who gives us a star on that Milvus GitHub gets a chance to win a prize, so let us know. Any photos you had from last night in New York, share them. This goes forward to anything in the future. Share those photos. We love to see interaction with the community. I'm just going to do my talk. I'll talk to Chris and Lisa and see if we can get their talks or have them scheduled for a future one. I know Chris is looking for another venue, so we'll see what happens there. But I'm going to give you my talk today. Again, a lot of other stuff to talk about once we're together again in person, and we've got pizza and all that kind of fun stuff. So my talk is unstructured data processing from the cloud to the edge. These slides are available. If you haven't seen the link in some other place, you can get it right here. I uploaded them already to make sure everyone could get them and follow along. I'm going to do a quick introduction about all this stuff, go over some AI use cases, look at some edge devices. Very shortly, I will bring one into one of the events, so you can see that in person. I know we had this discussion, and some people weren't sure what a vector database was. It is the place where you're going to put your unstructured data. And based on studies out there, almost 80% of the data in the world is unstructured. And what's nice is vector databases designed to work with all these different unstructured data. And this can be text, images, video, audio, binary data, all kinds of different stuff. Now, traditional databases aren't going away. If you need to exactly match things, they work pretty well. You put in the word street, you'll find the word street. But there's no context, semantics, meanings. Well, what do people really mean? When I ask for an apple, do I mean I want to eat an apple, Apple computer? There's a lot of subtlety there, and a lot of that is hard to understand unless it's been stored as a vector. Now, so there's knowledge base, bunch of documents out there. We apply some deep learning models. This converts us into a vector. A vector is just a big array of numbers, which makes a lot of sense to the vector databases and makes a lot of sense to models, which makes it very easy for this to power different types of applications and search. Fortunately, with the power of AI and how it's been improving, this has made all of this possible recently. Search by probability, because we can analyze common data sets that were used for building up things like NLP and image classification. And fortunately, there's a bunch of models out there like Word2Vec, a bunch of CNNs, and Deep Speech allowed us to find a way to take this unstructured data, build embeddings, map things like word, images, videos into these high dimensional vector spaces so that you can make this possible. And obviously new AI models have been coming out last couple of years, which are pretty powerful, like BERT and VIT and CBT, and made this so you can really start doing this semantic analysis of all these different unstructured data. And because of this, you really need a database that allows you to take advantage of this. So, support for all the different use cases that you want, lots of different data requirements. You need to be flexible depending on what you're doing, and you need to be able to handle ever expanding, very large data volumes and complex and large search demands across that data. So you need to be able to scale who knows how large when you consider how much unstructured data you have. Think of it, every email, every document, every log, every image, every video can be massive. But you still need it to come back right away. People expect things to be real time. I want the data right now. I need it right now for an answer, or I need to get that information back quickly to send that to a model to get data back. So what are you talking about, Tim? I'll dive into demos after we go through the slides, and you could try this one out yourself. We have this hosted one. You upload an image, like I uploaded one of my cat, and it finds similar images. I did my cat with no background, so it's looking for gray or no background cats of similar color, which I think it did a pretty good job, and you could try that out yourself. Again, we'll show you the demo. To me, instead of showing you a lot of slides, try to do demo. But, since we're not in person, I'm going to go through some of the background, because you could fast forward if you're like, oh, I know this stuff, Tim. Okay, well, grab that little bar and move it across. So, obviously, high performance search is important. But there's some other things you need to do with this data. It'd be nice if it all magically showed up once, and I did one-time vectorization, and we're all done. Well, that's not how it works. That's not how it works in a database either. You've got CRUD, man. You got to create stuff. You got to read it. You got to update it. Maybe delete it. You got to do that. You need your data to be up to date. You need the latest possible information as soon as it's available. So you get that data back for all your searches. It's got to be securely stored and persist regardless of what crashes, what restarts, I lose a drive, all that. You don't want to lose data. You want it always available. I want to be able to search, retrieve things instantly, always. And we got to scale out. I'm going to add 1 million more documents. I better be able to continue doing all of these operations at scale, fast as possible, as you'd expect with any database. You need to have your data managed. I need to ingest it, index it, query it. I need to back it up. I need to migrate it. I need to be able to recover in case something goes wrong, or maybe something goes right. I got a new platform coming. Let me start, storing it in a bigger system. Someone gave me a giant double the size system, more RAM, more cores, more machines. That's great. It should be pretty easy to operate, and not care where it's running. Obviously, a lot of people are going to run this in cloud, but you may have your own on-premise infrastructure, especially for things that may need security or may be so massive that you don't want to pay for that data storage and migration. So you might need to be an on-premise. You might need to have them in both places. You might need to move between them. You definitely need to observe this, monitor, make sure your health and performance of all this is running optimally and nothing's about to crash or run out of disk space. You need to have a lot of different apps and a lot of users using the same database without security or other kind of nonsense getting in your way. Fortunately, Milvus is there for you. It is run by the Linux Foundation for AI and Data. So it's not just open source somewhere. It's an open source community working on this vector database for a long time. And you could start with just a quick pip install, run it locally using Milvus Lite, reuse that code, use it against production or against the cloud, and integrate with all these different cool libraries that have been coming out, whether it's things from OpenAI, LangChain, Llama Index, so many out there, and has all the features you're going to need when you start going, well, I need this special library because it's a certain kind of image, or, sometimes I need a dense embedding, sometimes sparse, I need to filter it, I need to re-rank. There's so many things you realize once you get into it and once you have really specific requirements, specific types of data, things get to a certain size. Use the open source database that's been there and done that. I mean, I could just throw this in some random database that last week some guy spent an hour making sure that there was some sort of somewhat functional library kind of worked. Not really the best for efficiency in these high dimensional spaces. What kind of indexing they have? Maybe they have one. Maybe it's kind of works for some use cases. What kind of queries you support? Some. Can it really scale out? You're going to put 1 million documents in there? I don't know. Can you do analytics? How do you convert things? What are you going to do with these super computational intense operations for everything? Vector database is designed for that. Traditional databases do traditional database workloads. Awesome. Keep them separate. You can't do everything with one tool. You got to learn to use the ones that make the most sense. I could just use a library, write my own filtering, use generic hardware, use some data. I guess manually handle what happens with the data if it changes or deletes. Have, one kind of indexing. I mean, I guess if I keep it on my laptop, I don't have to worry about safety. It's not really designed for production workloads. Don't have the infrastructure for scaling, deploying, managing, doing all this in production. Unless you've got some of the top minds in the world working on it. I think you're better off with a database. Where does Milvus fit in? It was built to store, index, and query vector embeddings from unstructured data at scale from the beginning. With advanced filtering, hybrid search, durability, backups, replication, high availability, sharding, aggregations. If you're using a production database in your enterprise, these are words that are going to make sense and you've heard them. Going to have lifecycle management for the data, support multi-tenancy, handle high query loads, high insertions, deletes, full precision and recall. Your stuff is accelerated by all the cool stuff out there that helps in hardware, whether it's GPUs from our friends at NVIDIA, FPGA, ton of other things. If someone's doing research on it, we're working on it. Our engineers in the open source are doing pretty amazing stuff in massive scale. I mean, people are doing that already. And we handle all the use cases you want. You're like, well, what indexing you have? Do you have a couple? One or two? How about 15? And I think there's more than that. There's a couple more being worked on. You've got binary, sparse, disk-based, GPU-based. All the ones you've heard out, someone else has, it's in here. So you could optimize things, try different ones out, see the balance between accuracy, performance, cost, optimize where it makes sense for you. All the different types of searches, if it's a top K, if it's a range, search in multiple vectors, use metadata for filtering, group things together. Gives you all the flexibility that developers need to get back what they want, when they want it, how they want it, at the speed and scale they need. Support multiple groups of applications and users. You're going to want to spin up a database for every single developer and app? I don't think so. Have that shared, things partitioned, and collections that they can work with. Maximize the utilization of your platform, make things efficient, isolate things for security. It's the way to go. And support for all these innovative new compute types, whether that's Neon for SIMD, whether it's quantization, cache-aware optimization, GPUs, all the interesting hardware stuff out there and software stuff to optimize things is supported. And it's a real infrastructure coming from the world of Kafka and Flink and Spark and Pulsar and NiFi. I expect a distributed architecture so you could scale out to whatever side you need. That's not the case for the majority of vector databases out there. Fortunately, Milvus is very looking ahead to make sure things are optimized so I can scale up if I need more storage, if I need more query nodes, data nodes, indexing nodes. All of this can be done with load balancing, everything you'd expect in an enterprise production system, but fully open source. You don't have to worry about what are the licensing. This is Apache license. It's a real foundation out there. The great community of people working together to solve lots of different unstructured data use cases. Obviously, retrieval augmented generation is huge, really helps you in these chat apps, but that's just one app. I mean, recommender systems make really good advantage of vector database, text and semantic search. Search all my documents. Why not? Search similar images, videos, audio, molecules. A lot of cool people doing that. Anomaly detection for a lot of different things in events and databases, and being able to search over multiple types of data simultaneously. Multimodal similarity search is going to be huge. You'll just keep seeing more of that. And 100 billion vectors on Kubernetes is amazing. Just using a Helm chart, we get you started. Couple of clicks and you're ready to go in your Kubernetes environment. Work with all the toolkits out there you expect. We store stuff pretty smart. I don't know if we need to get into the every part of an entity, but you get the idea. And when I show you the demo, it'll start making sense. And you'll see how these vectors put things close together based on how related they are. And if you're interested, yes, there are some cats here. But let's look at some edge devices. Really, it's as simple as this. And I've got this running on multiple edge platforms, which is something you're going to need to do, which is pretty cool. Milvus Lite is running really well. You don't have to change much for running that somewhere else. Again, I can run a local LLM like Olama right on a device. I could do all of these things right at the edge. You know, facial recognition. Could do security apps, robots, what have you. Lower latency when we're running right on this device. Localized storage right there. Can be offline, secure, run inside a robot, run inside a moving vehicle, truck, autonomous things. Pretty cool. Milvus is there with your LLM and your AI and your ML models and your code working there at the edge. I've got an article on how to do this on the new Raspberry Pi AI kit, and you can check that out. Got another one doing this on a NVIDIA Xavier, which is one of their older devices, but we'll show you how to do that on one of the more powerful ones very soon. Let's look at some code. Okay, so give this project a star and let us know, and we'll put you on that list to win some cool stuff. It's a great project. Everything you need is here to get started, whether you want to build it from scratch or use it in Docker or whatever you're using it for. But let's look at a couple of demos. So I can run Milvus in Docker, Kubernetes, lots of different ways, or in Milvus Lite. Here I'm running this in the free area of Zilliz Cloud in a serverless environment. And I just wanted to show you a couple of collections I have and then show you how we got them. So this is New York street cameras. And I've got some metadata extra JSON fields here, plus my vector. And just to show you what kind of data we're putting in here, I've got this lat and long so I could do it with maps. Got travel advisories. This is from RSS that I've converted into JSON fields plus our vector to find stuff. And finally, this is New York City collisions, another source of data here, as you might find. And it has a vector and all the metadata fields we might need there. Remember I mentioned you could do that search online. We have a demo you could operate on your own really close. Let's see, what kind of data? Do I have any cool cats lying around? Oh, I hope I didn't move my cat somewhere. I can't remember where I put him. That would not be cool. Well, let's see. Do we have a cool cat? Cats. We're going to pick a random image and hope for the best. Oh, it's a cat. That's kind of surprising. And you can see we got similar things there. I don't know if that's that similar. But he is a kind of a silly bent cat. And you got all cute fuzzy stuff. That makes sense. We also have a cool one out there for chatting with documentation for different projects. And you can see it has various suggestions of common things here. And you could get access to this full source code, just to give you another example of a demo. Now I have a notebook here that is working with different things in Milvus. And this one I'm connecting to Zilliz. And I will connect to this schema if we didn't create it. Let me make sure I have this connected. Yep. And I'm going to build a corpus here. This is UNBM 225, which we've got an article on. And using a couple of example documents, we're going to fit the corpus, get our statistics there. And then I've got a thing that strips out HTML using a Beautiful Soup, which is a great library. And I'm going through all this RSS, getting this in the right format, creating a sparse vector, plus a couple extra fields there. And then we just load this as it comes in, and we'll put that in our system here, and then we could do a query and see. Maybe we'll do a level 2. There's different warning levels for travel advisories. And we get a couple of them, increased caution because of blah, 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 just to give you an idea. We also could do that with street cameras. This one is doing a search. And we connect to Milvus in the cloud in my free area. And then we could do a search. I'm sending in an image. doing an embedding on it and using that to do a search, and then getting the results here. You can see a bunch of different ones coming through. The same for New York City data. Let's see if we have set this up here. We'll load a couple extra rows here. And then this is looking at crash data in different parts of Manhattan. And then we could search it when it's done. Could also do things like search for people. This one, I'm doing this with a local Minio instance. And we could store and retrieve different things there. That one's still running. We could do things like find incidents, and this one's against my local Docker. It's pretty straightforward to do these things. And I also have one running on a server. Let me go to that server if I could find where I have that running. Oh, did I lose my connection here? We'll reconnect. Or do I have it over here? Nope. Too many screens. Too many screens here. So let's see. Maybe I have that running over here. I don't need a Jupyter notebook everywhere. We in the right one? No, I wanted that Jupyter. Okay, I've got one running on my NVIDIA device over here. And what I'm going to do is run my demo, which is running against this Xavier Python. And what this does is it takes, creates a Milvus collection, so we got some place to store it. But let me show you something key here, is it's storing it in a local Milvus Lite database. So I don't have to connect to anything externally. I connect to the local database, get my feature extractor for images using ResNet, lots of options. Create my schema, my collection in case it's not there. Open the web camera from the NVIDIA, read it, store it, hit a couple fields, do some blip image processing, insert that into Milvus, send a Slack message. Pretty straightforward. So we could give that a run, see how that's going, and then check that Slack channel to see how that's going. Pretty straightforward to do, and using Milvus Lite means I don't have to do that in some production environment. I don't need to access any remote cloud or data store or something that costs money. It's just running right here, and we'll do that on other environments as well. But let's go take a look in our, oh, we got a bunch of new messages here. And these just came in. And you could see that we did, grabbed our raw image. And then the image where we added things that we were able to identify. And we uploaded that to Slack. So you get that. Plus, you know, some of the metadata. Let's see, what other ones do we have? Some of these were running during just before the meetup. And that one's going. There is a black television. Oh, it's looking at the TV. That one right there. See, they took an image right next to my hand. I guess I could put my hand over there. We could also do that for traffic or whatever else you may have. But my camera is sitting right here. I don't know what it's going to say when it looks at me, but hopefully it won't be horrified. But you can see we could do a lot of different things based on where we are and what we want to do. Pretty straightforward. I like this one because it gave me a pretty nice description here. Black television, green table. It's seeing my green screen behind it. So that's where we're using the blip for. But if we wanted to do the traffic one, we have the traffic one over here, and we could do different traffic cameras and have them sent over live to that environment. Pretty straightforward. And then we'll get different things show up on the Slack. And we could send them other places depending on what you want to do. I'd have people doing questions. Ooh. Man with blue paint on his face. I guess I need to shave, green background. It's not the worst. let's have that go back, look at the computer again, and not look at me. That's about it for the demo. Everything is listed and linked online, so you could find any of these example codes that you want to look at with the full source code, notebook, search display, all those sort of things that you might want to do. They're available out there. Pretty straightforward. Thanks for virtually attending. Sorry we couldn't be there in person. We will be there in a few weeks. So thanks.